Hello everybody. This is the fourth video in the How to Get Faster at the Rubik's Cube video series on the Fridrich method. This video will be going over 2-look PLL. This step, when used with 2-look OLL, will finish the last layer and thus finish the cube. What this section will do is, in OLL, you got all of the yellows on top, and now all you need to do is move the pieces around and put them into their correct place, or permute them. Instead of learning 2-look PLL, you could learn what we call 3-look PLL, which is learning 2 less algorithms than 2-look PLL. I don't think it's worth it just to learn 4 instead of 6, so I'm going to be teaching you all 6. However, I will make sure to tell you where the cutoff is for 3-look PLL versus 2-look PLL, so you know if you want to stop. The first step of 2-look PLL is the first look, obviously, which will be putting the corners into their correct space. As soon as you have solved the cross, F2L, and OLL, you will have a cube that can look something like this. There are 21 different cases. However, there are only 3 possible cases for how the corners can be placed. You can have only 2 matching, like I do here, with 2 reds, and the other 2 not matching. You can have diagonals across from each other, meaning none of them match, or you can have all of them matching. Of course, if all of them match, then all you need to do is turn it and have them line up, and then you've done the first look. However, if you only have 2 matching, you want to match them with their correct center, in this case red. And now I need to switch these other 2. I'm going to be using a permutation called the T-Permutation, which will switch these 2 corners. It will also switch these 2 edges, which you don't care about. The T-Permutation is closely related to the Y-Permutation, which switches 2 diagonal corners and these 2 edges, which I will be teaching you in a little bit. An easier way to remember these 2 algorithms, which are both about 16 moves long, is that there are 2 parts, Part A and Part B. If you perform Part A and then Part B, you will perform the T-Permutation. If you perform B and then A, you'll perform the Y-Permutation. I will display Part A and B on the screen, right up here. To do the T-Permutation, which will switch these 2 corners, you do Part A, which is R, U, R prime, U prime, R prime, F, R, F prime, Part A, and you'll get something that looks like this, and then you perform Part B, F, R, U prime, R prime, U prime, R, U, R prime, F prime. And that will switch these 2 corners as well as these 2 edges. And as you can see, that solved your cube. When performing the T-Permutation, there is one quick trick that I would like to give you. It's not really a trick, but it is an easier way to combine Part A and B for faster performance. When you're going through Part A, U prime, R prime, F, instead of doing an R, F prime, and then doing an F again, you can just do an R2, and then continue on with the algorithm with Part B. So once again, you do Part A, and you do F, and instead of R, F prime, you just do R2, and start into Part B. And that is the T-Permutation. Now, the third case for corner permutation is where none of them match. You can easily recognize this by opposite colors being on the corners. Red and orange are opposite colors. Green and blue are opposite. Orange and red, etc. In order to solve this one, match up 2 of the corners in their correct spot. Red and green here, for example. And then you want to perform Part B and then Part A to perform the Y-Permutation. Part B, F, R, U prime, R prime, U prime, R, U, R prime, F prime, which will bring you to this T. Then you do Part A, R, U, R prime, U prime, R prime, F, R, F prime. And that is the Y-Permutation, which will switch these 2 corners and these two edges. Once you have done the first look in 2-look PLL, you will have all 4 corners in their correct spot, matching with their correct centers, as you can see here. Then you will run into one of 4 cases. The first 2 cases I will be showing you are 3 edge cycles that will cycle these 3 pieces. The first one I'm going to show you is moving this piece to here, this piece to here, and this piece to here, or clockwise. That algorithm, R2, U, R, U, R prime, U prime, R prime, U prime, R prime, U, R prime. That switches those 3 and can be performed very quickly. The next one I would like to show you is these 3 edges, going in a counterclockwise fashion rather than clockwise like before. As you can see, this orange needs to go to here to be solved. Remember, position the 3 edges on the front of the cube here. The back one should be solved. Now this algorithm is the inverse of the one I just showed you. R, U prime, R, U, R, U, R, U prime, R prime, U prime, R2. And that will cycle the edges counterclockwise. This case does not have any edges solved, which means you need to switch all 4 of them in some direction. In this case, these are opposite colors here, so these 2 need to switch, and these 2 need to switch. These 2 here. So for this algorithm, it doesn't matter how you hold the cube, you just need to do the M slice is very important in this one. How I would recommend doing it is using your ring fingers here if your cube will allow it, and if not, you can just do that. M2, U, M2, U2, M2, U, M2. That is a very simple algorithm and will solve that case. It can also be performed very quickly. The final case is where, once again, all 4 need to be switched. But in this case, you need to switch these 2 and these 2. Doing the algorithm that I just showed you will not solve it. It'll just get you the same case in a different position on the cube. So what you want to do in this case, M2, U, M2, U, M prime, U2, M2, U2, M prime, U2. Once again, the M slices are very important. Also, since there are not only M2s in this algorithm, you must remember that the M slice travels like the L slice does. So this is an L prime, this is an M prime. If it went with the R, that would be an M, but it's not. So those are the 6 algorithms that you need to learn in order to solve the whole cube with 2-look PLL. I would now like to go into a few example solves to show you how to apply these algorithms. So, now you have just finished solving your cross, F2L, and OLL, and you come up with this case. First, you look at your corners. These 2 don't match, these 2 don't, these 2 don't, but these 2 do. So, since they're blue, put them on the blue side, and hold them on the left side, and do the T-Permutation, which will switch these 2 corners. Now, all of your corners are in their correct spot. Now, you look at your edges, assess the case, and perform the correct algorithm. In this case, the blue needs to go to the front, and this back one is solved, so I can do the counterclockwise edge switching algorithm. And that has solved that case. Once again, you have just finished solving your cube. You look at your corners, and you realize that they're opposites on every side. Which means that you have the Y-Permutation. So, it doesn't matter how you hold it, just perform the Y-Permutation. And now, with rotations of the U layer, you have all of your corners solved. Now you can assess your edge case. In this case, I have all 4 are not in their correct place, and you need to switch these 2 and these 2. So I'm going to do the very last algorithm that I taught you, which will switch these 2 and these 2. And that will solve your cube. I hope you found this tutorial helpful on learning 3-look or 2-look PLL, whichever one you decided to go through on, and I hope this allows you to get faster times. 2-look PLL, in conjunction with 2-look OLL, will lower your last layer algorithms, or steps, from 4 to 2. In the beginner's method, you had to get the top cross, put the edges in their correct spot, put the corners in their correct spot, and then turn the corners. In this case, now all you have to do is get all the yellow on top, and then move the pieces around. The next step, after learning this, is to go on and learn 1-look PLL, which is just 21 total algorithms that will solve every case that you could possibly run into after doing the OLL step. That video will be made in the future, and if it has been made, it will be in an annotation on your screen. So thank you for watching, and I hope you enjoyed this tutorial.